Hey everybody, this is Dark Guardsman, and I want to show really quickly something we're going to be doing with the mods. Now, this won't be something with the actual mod itself or features or stuff like that. This is something that we developers are going to do, and I'm going to try to push some of the other people on the team to also try to start doing this as well. Now, what this is I'm going to be talking about is unit testing. For those who are not familiar with unit testing, it's a technical term that we software developers use to describe the process of automating the testing of fragments of code. It's not very glorious, it's not very fancy in terms of like you as a user coming in and looking at it and be like, what is that, what does it really mean? But for us developers, it's a really, really cool thing because it lets us go in and say, I have this piece of code. I know this piece of code should do such and such things, but I want to guarantee that no matter what I do in the future, no matter what changes I make, this piece of code will always continue to do the same thing. And it's absolutely amazing because as modders, we're constantly working in an environment that's changing underneath us. Every time we update to a new version of Minecraft, it's like, hey, this has changed and now no longer this block works as expectedly. Or hey, Forge has updated 3 new versions so somebody changed something in the backend and now no longer the EMP tower goes off as it's supposed to be. Or hey, we just booted up into a sponge server and for some reason the threads are different and no longer the blasts no longer trigger as they're supposed to. These are like actual bugs that have happened in the past and we have no way to really detect for them except for to release the mod and then some user to tell us. I want to get to a point where we no longer release a mod that is broken. That was one of like the biggest things I wanted to do when I created the organization of BuiltBroken. Was the ideal is that we were going to build techniques that ensured that our content was broken before we shipped it and then fixed before we shipped it. It was kind of one of those weird counterpoints. I don't remember what the word is for it, but you basically name yourself the very thing which you are not. But unfortunately, modding is what modding is, and we still release broken mods, and we haven't got to that technological point yet. It is possible, though. It is something I knew was possible even back then because I had been exposed to what unit testing was. So let me go ahead and show this rather than continuing talking and you're staring at code going like, what am I talking about? Now, the ideal of unit testing, let me actually go into the one we're going to be talking about. So right now I'm working in a new branch. We're going to be working on implementing new command changes to the Blaster Root. Now the Blaster Root has been merged in and it has been released out as alpha version. I am still looking for people to test it and make sure that I haven't completely broke it. Now it does have some missing features because we removed features that we're going to re-add as add-ons to the main mod because it's much easier to maintain that content as an add-on to the primary mod rather than building it into the mod directly. I believe this will be cluster missiles. Will be one of them that'll be his own add-on because I want to sit there and branch that content out. This is the thought before anything had happened. This is the idea behind it, is that we would have an add-on where you would have a crafting bench and you would actually pick how your cluster missiles were developed and built because I didn't want to go back and restore the original crafting system for it. And I didn't want to sit there and try to maintain what we had was 2 cluster missiles. We had a conventional, we had a nuclear, and it was like, they kind of work, but they're kind of pointless. They're not very useful to most players. Most players would just kind of spam them out and do their kind of thing. So we decided I was going to go and make an add-on for that. But yeah, so we're working on command changes, rewrites happen. And with part of the command changes, I want to go through and test everything. Now, when I did all the work for this, I actually split out. We had like one command file, and that one command file did all of the work. So it was this big file, too much going on, too much to deal with, too much to maintain. So I'm like, hey, we're going to split this out as small as possible we're going to do. So we have the ICBM commands, which actually tracks everything. We then have an entry point for this, called command entry point. This is what the original command was, but then it got turned into this, and now it's just a thing that you call, and this will have ICBM, ICBM-C were the 2 command things. I think I've got it changed to just be ICBM now, because I was like, hey, nobody's probably typing an ICBM-C anymore, because that you could always type an ICBM, it would work just fine. So we have this, you have the entry point, then it has subcommands in it, and the subcommands are all listed out, and they're basically just help, lag, remove, and blast. Blast itself is also a subcommand, and the one we're going to be looking at is blast trigger. Now blast trigger was the original command where you would do ICBM space blast and then the name of the explosive, and it would set off the explosive wherever you wanted to go off at. Now this was designed for command blocks and stuff like that, so that way on servers people could do interesting and creative things by making maps, utility, stuff like that. And also meant we had a way to test things. We never really used it for testing because it was just far easier to go in and grab the rocket launcher from the mod and fire it off and do whatever you wanted to do. But it was an option. And the idea with this was going to slowly build into more utilities, and that's kind of what I'm hoping to get to before I merge this back into the master branch. Is that to add more utility commands, more things that admins can take advantage, more things that map makers can take advantage, and utilize this mod as more than just, I have a missile I can detonate. It can become a utility into building different varieties of maps. Like for example, I believe the missile one has been requested by a mod pack maker who wants to make a, I believe, World War I, World War II themed mod pack, and he wants to use the explosions from it, not really the missiles, to create this ambiance of an ongoing battlefield, even though if you're the only player in there. So have an explosion constantly go off and then regenerate the ground and then repeat the process, or just have the explosion go off. There's more to it, but there's that ideal. So we're looking at the splash command. The splash command has already been rewritten. I've already gone through and I've already done a ton of work with it. I've went in and made sure that all of the commands are now translated. So even the error messages are now translated, so that when you're coming in and you type the command, it will then send you a message to your client. The client will then translate it into your native language. So you're no longer having to stare at English-only commands when you're using chat commands. This isn't really that big of a thing because most admins who are working with this mod are probably familiar with the fact that they still have to type in English-based chat commands, although I've talked to a few people about a way around that. We're probably not going to do that anytime soon, but there may be a mod in the future either developed by me or somebody else that would make it so that way you can type in your native language for the commands as well. It would be interesting, but probably not a high priority. So we got the command, we have a handle command. The command then does its things, handles basically missing commands, handles unknown stuff, your standard command stuff. Now the thing I want to talk about is the unit test of this. Now the unit tests are the ideal that we're going to have a separate little folder structure. The folder structure, if you're doing this correctly and you're following kind of the standards unit testing, will mirror your folder structure of your main project. So you'll have ICBM, ICBM Classic, then we have commands, sub, blast, and so on. And inside here we have everything that's going on. So this is kind of that standard you follow. And then the other standard you follow is that you will take the name of the class file, so in this case command blast list or command blast whatever, and you'll put the word test on the end of it. This will be your test file. And inside this test file, the other part you start to follow is that you'll follow kind of naming out, okay, what am I actually testing? And then what subvariant of I'm testing. Now in normal Java, you're not supposed to put underscores in here, but this is one of the few exceptions where it's kind of allowed, because when you're writing commands, you often need to test, or when you're writing tests, you often need to test the same exact thing over and over and over and over again. I may be testing like 15 variations of the help command, but each variation is slightly different. And the way people used to do it is they would be like, hey, I'm doing like help server, and they would use the word test or testing help server or something like that. And it's kind of like, it works, but one of the other conventions you can try, and this is not required, people have tons of variations on how they like to do this naming scheme of the method. Because in reality, when you go into like JUnit 4, which is what the framework we're using for testing is JUnit. JUnit 4 and 5 do not require this to be labeled whatever. JUnit 3 did require you to use the word test in the front of your methods, but then they started adding this annotation up here, and this annotation, which there is a variation of this. If you're using JUnit 4, the imports are going to be different. So the framework we're using is the Jupyter JUnit system, which is JUnit 5 and beyond. So JUnit 6 will probably still use the word Jupyter, possibly. I'm not 100% sure. They may decide to rework the framework again. Each variation they do of it has different nuances of how you do things. We're using 5. I have my own framework we also use on top of this, which is Minecraft JUnit testing. I have built that up so that you can use JUnit 4 and 5 in it, even though it itself uses JUnit 5 internally to test itself. But with this, so we have these commands. In this case, I'm testing the help command. Very simple. How we do it, not so straightforward if you're looking at this and you've never done this. So in order to test this help command, we have to do quite a few different things. Minecraft is not really built to be unit tested, and you can kind of tell this going through it and looking at how it's designed. One of the ideals behind unit testing is you're testing a small fragment of code. With Minecraft, you can't test small fragments because everything is interdependent. If you want to test an entity, you need a world. If you have the world, you need a server. If you have a server, you need everything else associated and attached to this. You can't just break fragments off and be like, hey, I want to test maybe only the zombies walking behavior. You can't do that because you need the world associated with it. We call this in development social testing, because this test has to be very sociable and talk to other components in order to work. It bleeds over into integration testing. So if you ever hear the word integration testing, it's the ideal that you're testing connections along with your code. So you're connecting multiple fragments of code together and then testing that all those connected fragments do what they're supposed to be. Now the line between unit testing and integration testing is very blurry, because effectively a unit is anything. It's whatever you want to call it. So in my case, this is where I usually start using the word fragments. I consider this a fragment of code. But then this whole class may be considered a unit of code. So you can kind of see the nuanced difference of that, but you wouldn't test this whole thing. So going into this, in order to get the help command though going, we have to do various things. Now I have a test manager that I use. This is designed to help me control a lot of the tedious effort of actually running tests and getting tests going with Minecraft. Now, if I was working on a project that was not Minecraft based, I would probably not have to worry about this. Most projects I have developed outside of Minecraft are so well built and abstracted that you can indeed test really small fragments, or you can use a utility like Mockito to fake out connections between things. If you have never heard about Mockito, it's really useful to go look into for testing. Our EMP system, which I'll go into another video later, actually does use Mockito for testing. It kind of works. It's not great, and you can use it for Minecraft, but it's a little sketchy because Minecraft, again, is not built for testing. It's also not built to be mocked out. Now, the idea of a mock is you're basically faking something, but it's not quite a fake. There's a whole paper that goes into detail what the difference word between a dummy, a fake, and a mock is. And that really it comes down to is a dummy would be an empty class that has nothing in it. A fake would be you taking a dummy and you're actually putting some implementation into it. And then a mock is you're surrounding something and you're pretending to be that object. So you're mocking it. You're doing kind of like the Mockingbird does, where if somebody talks, that Mockingbird can talk back to you. That's the kind of idea behind it. And there's also a thing called spies, where you can wrap around the component, let the component run the normal way, but then spy on its call logic. And it's very useful if you want to test really deeply nested logic. But in our case, we have a test manager, and this test manager is wrapping around fakes. I have actually created a fake for a world, a server, and a test player. So I have a fake world server, test player, dedicated server. I have other things in here as well. Now, the way this test manager works is I can call get world. Get world will then make sure, if I don't already have a world, it'll initialize the world. But what it'll do is it'll also call get server, which will then do the same thing. It'll go, hey, I don't have a server, and it'll initialize the base game. This is very important because Minecraft cannot operate without this being initialized at all. And keep in mind, we're not actually launching the full game when we're doing this either. That would be way down the line of testing. That would definitely fall on the side of integration testing if you're launching the full game. I believe at my work we actually call it system integration testing, simply because the terminology gets so confusing. We're like, hey, you're testing the whole system. You're testing integration of the entire system together. But you have to call this, which what this does, project of the day, just no, don't ignore that. Intel just had some weird bugs lately. This is one of them, where it actually does some things. But yeah, so this will go through and register, and this just goes through and registers everything. Make sure the blocks are up there, make sure the sounds are up there. It does all the work to get everything started. It does not actually load any of the resources, so you don't get textures, you don't get renders. That's done by another system. So this will just quickly initialize to make sure, hey, every block is registered. So you now have all these blocks available in your test. You can now place them into the world. You can do whatever you want. Now, theoretically, if you're doing unit testing properly, you want to avoid this, but because of the way Minecraft is designed, you cannot avoid doing this. And the ideal reason you can't avoid doing this is if I do control in here, and I go to the blocks class. Really? Oh, it's because it's not sorting by all. I never liked how it did that. We go to the blocks class. If you look in here, okay, so nothing's in here initialized, but this does initialize itself, and it's done via class loading. It's really horrible. I hate when I see code done this way outside of Minecraft, is it means that there's a lot of stuff wrong, but it'll hit the static block, which means anytime anything calls block class, it hits the static block, which then checks to see if the registry is running. If it's not already registered, then it basically crashes out everything. Your test will fail. You can't touch anything in this file, which is impossible to do because I enter dependency of everything. There's basically, Minecraft is spaghetti code, if you've ever heard the terms. There's one thing linking to another, linking to another, linking to another, that then links to itself, that links back to the first thing, that then links back to 5 other things, which all link back to the first thing. So anytime you call like one section of Minecraft, it tends to load the entire Minecraft project, which is really bad. If you're doing code outside of this, you design your code to intentionally not do this because, one, it makes it code hard to unit test, but it also means you can't rip code out and replace it. Minecraft is the same way. You can't just pull pieces of Minecraft out and put a new system in there, like replacing the biome system or replacing the chunk system. It can't be done because it's so hard dependent on each other. Though they are working on that. You do see improvements over time of this getting better, but this is one of the examples where it sucks to do. And it at least is better, because this is Minecraft 1.12. Back in the day, when you're working on older versions, it actually was nearly impossible to unit test because of how Minecraft behaved. 1.7, for example, you had to mock the class loaders. You basically had to fake out the class loader and say, okay, I need to use Forge's class loader to load everything. This was really complicated and meant that people didn't unit test in 1.7 because you just couldn't really do it. And when you did see unit test, you usually saw unit test involving that person's own mod code and nothing else. Like if they had to touch anything remotely Minecraft, they avoided it like the plague. Though I did figure out ways around it, but whew, that was a a tough thing. But yeah, so we got the test manager. It does all that stuff, does the world for us. We then have a dummy command center. This is the wording's wrong for this because this is basically a fake command center, because a dummy wouldn't have anything, a fake would have stuff in it. So I've basically made my own implementation of a command center, and it just does basic stuff. It's like, hey, I got world, I've got a server, I've got a position, I can track messages. Every time you send a chat message to this thing, it keeps hold of it, so that way I can come back in and go, hey, what chat message did you get? Did you get help command? Did you get an error? What did you get? I can actually track that. I can actually track the actual logic beyond that too, but that's a whole other thing. We then instantiate the commands. We instantiate some extra data. Now the way the command's done, it's kind of a little bit too tightly coupled with the explosive registry. And there are ways for me to get around this where I could fake out the explosive registry completely, but it's too much to go through work-wise, so I just was like, hey, we'll instantiate the explosive registry. Ideally, in a real project, you wouldn't want to do this, but because of the way Minecraft's designed, I was like, I'm going to be doing this for like everything else anyways. There's no point dramatically changing the mod just so I can test things. What you'll hear outside of Minecraft type projects is that that's the wrong way of thinking, and that you should design your code for testing. There's a whole idea behind test-driven development, and then ensuring your code is built to be tested rather than testing or building tests to work around your code. It's a whole concept, and I really would love to get in a video about that, because it's something I'm going to be applying more and more in the future, because TDD, as it's called, or test-driven development, is really, really nice for writing code. It prevents you from scope creeping and prevents you from making really messy code, because what you do is you write the test first, and you set up your failure criteria by like, hey, if I have a sword, I expect the sword to swing and do damage, and you set that test, and then you make the sword, and if the sword doesn't swing, it fails one test. If it doesn't do damage, it fails another test, and it tells you exactly what you've messed up on without ever launching the game. You don't have to run the game and be like, hey, well, I pulled this sword out of creative tab and then I swung it, and I'm like, why isn't it doing damage? And then debugging, I'm like, why isn't it doing that? And then 2 hours later you figure out, oh, I forgot to set this float value. The unit test will tell you that right away. But yeah, so getting in set up, we also have cleanup between tests. So this is kind of a useful look at. So before each test run, so before each of these blocks get called, it'll set up the explosive registry, it'll register everything else. Now I could do this probably once for the whole class file, but I decided it's better to clean it up between each to ensure that we don't have dirty logic between them. When you're writing unit tests, one of the biggest things you want to focus on is making sure that you're not impacting the next test. Each test should be isolated and should not interact with the next test after it. This means if you're setting some global data, you're setting some properties, you want to make sure you clean it all up, you don't leave stuff sitting around, so that way when the next test runs, you could end up with a false positive. Say for example, you were testing if you could place a chest from all 4 directions, and you didn't clean it up after the second placement, and third and fourth placement passed because that second chest is still there, exactly where you went to go place it, and you never checked the other ones. You could think that your codes are working when in reality it's not, because the third and fourth chest never placed, they failed to place. And there's a second chest there. So the test runs and goes, hey, I see a chest, so clearly the test placement worked. Obviously we did have other things in place to check for it, but it's an example. We also clean up between tests, so clean up, ensure the test managers clean it. This basically scratches the entire world, so I don't have to worry about that chest example, but it kills the world out, kills the server out, kills off everything. Make sure that we're 100% clean, so then the next time we run, we start up a new server, we start up a new Minecraft everything. It's good to go. Now the server we do start off is also not a real server. It is faked out completely, so there's no ticking logic, so I don't have to worry about ticking, so we don't go from tick 0 to tick 1 to tick 2. That doesn't happen. I don't have to worry about things spawning. I don't have to worry about any of those mechanics. It's really just a server that sits there and goes, hey, I exist. I loaded your whitelist and stuff like that. I loaded all the commands, all the properties. They're all there ready to go. We then have teardown after, so this is an after all. If you do after alls or before alls, they do have to be static. The method names don't matter. You can call them whatever. This can literally be this and it will still run perfectly fine. Now, IntelliJ will complain because it's not English, but whatever. But getting back to the commands, so after we've set up all of that, and this is kind of the thing that usually scares people off of testing, there's a lot of prep work up to get even the most basic test working, for Minecraft at least. If we were not in Minecraft, there wouldn't be this much effort, and I can probably show other projects where it's a lot simpler to deal with. We did all that, we then get our command, we then call display help. This then uses the dummy sender, which then adds messages to it. I go, hey, I want to assert that I should only ever see one message. That should all the message I got back. Then I want to assert that message should be this. I should have got back trigger, ID, dim, XYZ scale, and got that back. And I can actually run this test. I can click run server. I just hope it actually does run because I didn't test this beforehand. Yeah, it runs. And this will run, and we'll also see some stuff like this. Now, my project's not set up properly, so it thinks JUnit 4 is still in here, so it's trying to run JUnit 4 stuff. There is a fix for this, I just haven't bothered fixing it. It's the ideal that we have. Well, we can add JUnit Vintage to this, but there really is no JUnit 4 testing in here. It's the ideal is that the library for JUnit 4 is there because ICBM uses dmod script system, and dmod script system imports JUnit 4 for us automatically because that's the system we were using for all mods way back in the day. But this runs, and we can kind of see it. It does actually start a fake server. Nothing will tick or load. That's the message I actually added. It then loads dimension 0. It does this twice for some reason. It's the same world in both cases. And it's really, I think the server by default loads dimension 0 for you. And then I ask, hey, I also want dimension 0, and it loads it again because it unloaded probably. And then it also says, like, hey, you loaded achievements and stuff. There's messages that pop up here. I've cleaned up most of them, but you get a few. And then the test runs, and then we're done. Now, ideally, if you're running unit test, you really don't want any chat messages in here because you want to save this for actual errors. But you will still have them occasionally. It does happen. You can't avoid them always. But the server thing itself, the only thing it had was unload dimension 0 because after it ran teardown, and teardown ensures that server unloaded and ensures that the world inside of it unloaded. But we ran it, we got all our stuff. Now we also have a version for the player, so we have an actual test player we can run. We can call getPlayer, which is a fake player. It extends NDD player, I believe. So it doesn't extend the fake player class, it extends the MP class, so that way we have something that in theory will trick most mods into believing it is a real player running around the world, which is intentional because I do want to ensure that we do have something. It does have its own game profile. It's just using some random string. Hopefully this is not somebody's real information. And then it just says my name is unit tester. And it goes through and it has some basic stuff in here. Like I can do the same thing. I can track messages. I can track stats. So if you do get an achievement, I can be like, hey, you got an achievement, or well, in this case, it would just be a stat increase. Like you mined like $5. I can check that stuff, and it does come in here. I can look at that. I also have some things faked out as well. And there's some other stuff. Like there's some stuff I had to do with to make this work. There's also a reset which clears his inventory, clears equipment. So if you picked up an item, I can then clear it out of the inventory. I can check for that kind of stuff. So we have all that. The big thing, which is really, really useful, and I don't think very many mod developers who even do unit testing really understand how to do this, is called Parametrized testing. This is one of the new features of JUnit 5. It's the reason why I switched to it, because I discovered this while working on atomic science. I was like, holy mackerel, that is a really, really useful system, because in atomic science, what we were running into is I needed to test permutations. I needed to test, like, okay, if you place this tube in this orientation connected to this block at this position, what does it do? And I needed to do that, and I needed to do that in such a way where I wasn't working really, really hard to do it. And I figured out, oh, you could use this stream system. I could set up a stream of arguments. I can do this. Now, this in this case is a manually generated stream, but you could automate this generation. You could say, okay, I want to do all 6 rotations. I also then want to do blocks on all sides of that. I then want to control basically how it works. And you can generate all that, which we do in atomic science. I'll make a video talking about it at one point. We'll go into this one. So we have this provide bad command input, and then we have a function down here which has parameterized test and goes, hey, my method source down here. Now there's articles online, so if you do want to learn about this, there's a lot more you can do with this other than method source. You can provide a list of strings, you can provide an Excel sheet, or I think it's a CSV of test data. There's I think 15 or 16 different options of what you can do other than just a method source. As well, it is optional to actually name this. If I wanted to do this properly, I could call this up here the same as its test. It would automatically find that. However, I am using this in 2 locations. I've got basically, actually no, this is the one I'm using too. I have another one down here that has 2 separate inputs. But in this case, we have all this bad commands we want to run. We want to check to make sure that if I put bad command data to this command, I handle it. I handled exactly how I do it. In this case, we're going to go, hey, here's our actual command string. This is what happens when you type in your chat command into Minecraft. It actually splits it into an array of strings and then feeds it into the command. That's how we kind of handle it. But in this case, I was like, hey, I command. I then know I'm going to get this error string back. I then am going to test for a player, or in this case, I'm going to test for a server. And it comes down here and it goes, hey, I'm going to construct your test for you. Okay, you wanted a player? I'm going to instantiate a player. I'm then going to assert that when I call this command, I got a wrong class exception. I'm then going to grab that exception and then assert that exception's message is what you wanted it to be. So we got 2 different tests going here. In theory, if we were doing this and we were trying to stay true to the correct theoretical way as possible, you would assert only one thing per test, but this is not always possible to do. So in this case, you would do more than one assertion. And you do kind of see this in actual production-based projects as well, where you'll see a project and it will have like 15 assertions in it. It's because there's no way around it. I believe at work we have a database thing that we run, and it has an assertion, and its way of doing assertions is a lot different because it's a spring system. So instead of doing assertions equal, we do like assertion, and then it wraps around the object, and then wraps around, I believe, the actual set of the database, and then that gives us back an object, which then is wrapped, and then we ask, okay, did our object give us a 200 response back? Did we get back this information? Did this information come back in this format? Did we get this number of count? And then we do basically a chain insert, which is assertion, which is really cool. I wish we could use it in here, but I don't know which library it is, and I really need to take time to check it. But I do most of the JavaScript at work, so I'm almost never in the Java code anymore. But yeah, so we have that. I have all this test, and let's just test the command. So it's not glorious, and I focused on the commands here for doing this testing because it's something we can really easily work into. I can sit here and test it, and I can ensure that this code actually does work. So while I'm working on updating the commands, I can make sure that all of this works before I ever launch into the game. I can also do some cool things, like here's our test for everything. I can run, okay, I want to see my coverage. I want to see what coverage percentage of my testing I have for every single thing. And it'll go through, run all the tests, and it'll go through and make sure all this is running and everything else. And it just kind of slowly goes through and validates things. It doesn't take very long. It takes about 5 seconds. It's pretty fast on this machine. On my work machine, it's like 25 seconds. And you will see as you go, this will get slower and slower. And it will come up here, and it will actually give us some assertions here. Now, this is going to track over pretty much every single thing you're loaded. You can narrow this down, but I can actually check everything else. If I wanted to say, okay, what percentage of Minecraft code did I cover? I go to Mojang, which obviously we're not doing things, but I can go to BuiltBroken. In this case, this actually is our code. It'll tell me that my JLib code got covered, and this is the cool thing with JUnit testing, is you'll get a coverage percentage on code that you didn't actually specifically test, because that code called another piece of code, which called another piece of code, which called another piece of code, which just so happened to be part of your system, and then you tested it indirectly because you needed to also test your code. And in this case, I believe we are probably testing the vector library. Now, this is, I think, one of the few libraries I actually do have unit test on. Unfortunately, this is pulled in manually into ICBM, so it's not downloaded externally and used to build with. So it's going to get tested. It's going to be like, hey, you have 100% class coverage, you have 3% massive coverage. You haven't really called anything, is what it basically is telling you. And own IntelliJ will actually show you what's going on. And why do we actually call? I think we call pos2d because the EMP tower uses it to determine distance without considering Y level or something like that. There's a usage for it, definitely. But yeah, so we got all this, and we can actually go into our command trigger. I can go in here and go, okay, what piece of code did I miss? What have I not tested yet? And this will only just tell me what I've missed. It won't tell me what cases I've missed. So you could have 100% test coverage and have only covered like 5% of your actual cases. Now the difference between those is that I could have, say, 1,000 different things that came through here, and I could maybe only be doing like 10 of these down here. But then I've only tested, say, like 15 here, and it'd be like, oh, you got 100% coverage, but you've not tested all 1,000 cases. Now, realistically, you're not going to test all 1,000 cases, but there may be a whole bunch you want to test. Like, I don't have a test for putting null in here, although null would be handled by this case down here. So there's not one down there. It's the reason why you'll see that. But this will give you a rough estimation. It will tell you, like, hey, what have you missed? Okay, you've hit this 12 times in your testing, or you've hit this 24 times. It used to actually tell you what branches you were missing as well. It doesn't do that anymore, and it may just not be IntelliJ may not do it, but I think it was there's actually a framework program you can run your test through. It actually does a much stronger job than this does, but we're using like the base thing. I think it's like a Jacko reports or something like that. It does a much stronger run of this information. But we can go through and test everything and see if it's running, and then I can ensure like everything's working too when we go through this. So that way when I actually do launch the game and actually do run these commands, I don't really have to worry about them. It also means I don't have to spend time really testing them either, because every time we do an update, I just run these tests and it goes, hey, everything's working. I don't have to come back through and test everything, which was a really huge time sink for mod development, because it was like, hey, every single time we did an update, we had to go through and test every single piece of the content because we didn't know if we broke something accidentally, especially when we're doing large refactors and moving class files around, changing core mechanics, stuff like that. With unit testing, I can change all that, I can move stuff around, and it will just run through and test everything and ensure like, hey, your stuff is working, at least as far as we understand. Now to add to this, once we get through unit testing, then we'll throw integration on it, we'll throw system testing, and then we'll throw like live testing on top of that. So then you'll have these several different layers of testing, and you'll be able to go through and be like, with a pretty good confidence, be able to release a build to the public with very minimal human interaction of testing. So you would only test what you actually changed. So if you added a new explosive to the game, you would only go test that explosive. You wouldn't have to test like everything else around it to make sure you didn't break everything. But we'll leave this here since it's kind of turned into a 30-minute video, even though it's supposed to only be a short video. And hopefully that introduced it a little bit here. And we'll do more videos covering kind of more core concepts of this, either as part of Minecraft mods or as part of like independent projects. And I still want to really get into doing more than just Minecraft on this channel. But I'll see you all later.